If you ever watched a heavy freight train cross the American landscape in the early 1900s, you almost certainly saw one. A Baldwin steam locomotive. Thousands of them. All forged in massive iron foundries in Philadelphia. At its peak, the Baldwin Locomotive Works controlled the global motive power market, exporting mechanical giants to every corner of the earth. They survived the Panic of 1837. They survived world wars, economic depressions, and fierce domestic competition. They built an entire industrial city spanning 600 acres just to keep up with demand. And then, a few decades later, the massive factory gates were permanently chained shut, and the most dominant transportation company in American history simply ceased to exist. So how does a corporate empire that built over 70,000 locomotives and practically invented the modern railroad industry get completely wiped out by a technology they refuse to understand? This is the story of how the undisputed king of steam power was quietly destroyed by the diesel engine. Chapter 1. Humble Beginnings of a Jeweler. Philadelphia in the 1820s was a city of quiet craftsmanship. In a small shop on a cobblestone street, a young man named Matthias William Baldwin spent his days hunched over a workbench. He did not work with massive iron castings, he worked with gold. He worked with silver. He was a jeweler and a silversmith. He understood microscopic precision. He understood how tiny gears meshed perfectly together inside delicate pocket watches. It is a peculiar observation of industrial history that the man who would eventually build the heaviest and most powerful land machines on Earth began his career crafting the lightest and most delicate ornaments. But that exact precision would become the bedrock of an empire. By 1825, the American industrial landscape was beginning to shift. Consumer demand for manufactured goods was growing, and Baldwin recognized that the jewelry trade offered a limited ceiling for ambition. He formed a partnership with a skilled machinist named David Mason. They started manufacturing small tools for bookbinders. They engraved complex copper cylinders for printing calico fabrics. The business grew rapidly. Soon, hand power and foot pedals were no longer enough to run their expanding shop. They needed mechanical power. They needed steam. In 1827, commercial steam engines were massive, clunky, and highly inefficient beasts. They consumed mountains of expensive coal and took up enormous amounts of floor space. Furthermore, the manufacturing world lacked standardization. Every bolt and nut had to be cut by hand. If a machine part broke, you could not simply order a replacement. You had to fabricate a new one from raw metal. Baldwin looked at the available steam engines on the market and rejected them all. He decided to build his own stationary steam engine from scratch. He applied the exact same microscopic precision he used on silver watches to cast iron cylinders. The result was a vertical engine that generated 5 horsepower. It was compact. It was remarkably quiet. It ran smoothly day after day without breaking down or stalling. The engine was so beautifully engineered that it did not just power his machinery. It served as a walking advertisement. Other manufacturers in Philadelphia came to his shop just to look at it. They saw how efficiently it ran and immediately asked him to build similar engines for their own factories. Before he knew it, the jeweler was running a highly profitable steam engine manufacturing business. The bookbinder tools were pushed aside. Steam was the future. Then came the spark that ignited a transportation revolution. In 1830, news of successful steam locomotive trials in England crossed the Atlantic. Franklin Peale, the ambitious proprietor of the Philadelphia Museum, wanted a piece of the public excitement. He asked Baldwin to build a miniature working locomotive for public display. Relying entirely on written descriptions and rough sketches of English engines, Baldwin accepted the challenge. In April 1831, his tiny locomotive began pulling 2 small passenger cars on a circular pine track inside the museum. The public was absolutely mesmerized. The executives of the Philadelphia, Germantown, and Norristown Railroad were among the spectators. They were building a 6-mile track out of the city and needed motive power. They confidently asked Baldwin to build a full-scale, operational locomotive for their line. The request was borderline absurd. Baldwin had practically no specialized tools for heavy manufacturing. He had no massive foundries. His mechanics had never seen a real locomotive up close. Cylinders had to be bored manually using primitive chisels fixed in blocks of wood. The blacksmiths did not know how to forge such large pieces of iron. Baldwin himself had to do much of the brutal physical labor, inventing the manufacturing process as he went along. On November 23, 1832, the machine was finally ready for testing. He called it Old Ironsides. It weighed over 5 tons. Its large wooden wheels were fitted with thick iron tires. When the fire was lit and the steam pressure built up, Old Ironsides moved. It worked brilliantly. It reached speeds of 28 miles per hour, an astonishing velocity for the era. It was one of the very first successful steam locomotives built entirely in America. But the triumph brought immediate frustration. The railroad executives complained that the locomotive wheels slipped on the wet rails. They argued bitterly over the final price, initially refusing to pay the agreed-upon $4,000 and eventually forcing a settlement of $3,500. Baldwin was utterly exhausted. The extreme stress of building a massive machine with improper tools had drained him financially and physically. He reportedly swore that he would never build another locomotive again. He lied to himself. The immense challenge had changed his perspective entirely. Matthias Baldwin realized that America was a vast, untamed continent. It would need thousands of miles of iron roads to connect its cities, and those roads would need mechanical horses. He had just built his first one. The jewelry tools were permanently boxed away and the foundation of the Baldwin Locomotive Works was officially laid. Chapter 2. Building the Foundation of a Giant. After the exhausting but successful delivery of Old Ironsides, Matthias Baldwin realized his makeshift shop was no longer adequate. The American railroad system was expanding faster than the iron mills could roll the tracks. Dozens of new railroad companies were securing charters, and every single one of them needed reliable mechanical horses. By 1834, Baldwin recognized the immense scale of the incoming demand. He moved his entire operation to a significantly larger facility situated on Broad Street in the heart of Philadelphia. It was a massive financial leap of faith. The new shop was equipped with heavy industrial machinery, dedicated foundries, and specialized tools that he often had to invent himself, because they simply did not exist anywhere else in the commercial world. Baldwin did not just assemble locomotives, he relentlessly re-engineered them to survive harsh environments. Early railroad tracks in America were notoriously terrible compared to their European counterparts. They were uneven, hastily laid over rough dirt grades, and full of sharp curves that caused stiff English-built locomotives to derail constantly. Baldwin studied this fundamental mechanical failure and designed an elegant solution. He introduced the flexible beam truck. This critical innovation allowed the leading wheels to pivot and move independently of the rigid main boiler frame. It enabled the massive, heavy engines to navigate sharp, uneven curves without jumping off the crude iron tracks. It was a brilliant piece of practical engineering that made Baldwin locomotives perfectly suited for the rugged, unpredictable American terrain. Furthermore, he invented new high-pressure steam joints that resisted leaking under extreme heat, and he ground his iron cylinders to microscopic tolerances that other rival manufacturers considered physically impossible. The business was expanding at a staggering pace. Production numbers climbed year after year. The Broad Street facility was operating at maximum capacity. Then, in 1837, the American economy completely and violently collapsed. The panic of 1837 wiped out regional banks, destroyed lines of credit, and halted ambitious railroad construction projects almost overnight. Customers who had ordered custom, expensive locomotives suddenly could not pay for them upon delivery. Baldwin was trapped in a financial nightmare. He had invested heavily in his new plant, purchasing mountains of raw iron and coal on credit to meet the previously soaring demand. When the market crashed, he found himself drowning in insurmountable debt. His financial backers panicked and strongly urged him to declare bankruptcy, which would have legally erased his massive debts and allowed him to walk away without personal ruin. Looking back at the industrial panics of the 19th century, it becomes clear that long-term corporate survival rarely depended on having the best product alone. It relied almost entirely on the absolute, unyielding personal integrity of the founders. Baldwin flatly refused the easy legal way out. He called a meeting with his creditors and made a public, solemn pledge to pay every single entity down to the very last penny, even if it took him the rest of his natural life to do so. It took 5 agonizing years of strict financial restructuring. Baldwin managed the loud, smoky factory floor by day and negotiated with anxious bankers by night. He secured crucial loan extensions, ruthlessly reorganized his manufacturing processes to cut wasted materials, and focused intensely on building the most reliable, durable engines in the country. Slowly, the national economy began to thaw and recover. The railroads, now resuming their expansion westward, desperately needed new motive power. They explicitly remembered the Philadelphia manufacturer who had honored his debts when everyone else had defaulted. Orders flooded back into the Broad Street facility in record numbers. Baldwin paid off his final remaining debts in 1842, cementing a golden reputation for financial stability that would define his company for the next century. With his finances completely secured and his reputation glowing, the growth of the Baldwin Locomotive Works became truly explosive. The Broad Street plant physically expanded, aggressively swallowing up neighboring city blocks. The daily workforce grew from a small handful of mechanics to hundreds of highly specialized laborers. Blacksmiths, boilermakers, machinists, and expert draftsmen worked in heavily coordinated shifts. By the 1850s, the factory was churning out dozens of massive locomotives every single year. They were shipping these iron beasts to the expanding western frontier, across the agricultural South, and into the industrializing New England states. Baldwin had successfully transformed his chaotic, improvisational workshop into a highly organized, relentless industrial machine. He standardized mechanical parts wherever he could to increase production speed, yet he carefully maintained the engineering flexibility to custom-build engines for any railroad's specific geographical needs. He was no longer just fulfilling isolated orders for local transit companies. He was dictating the overall pace of American industrial expansion. The deep foundation of the giant was now firmly set, and the manufacturing empire was completely ready to conquer the global market. Chapter 3: The Golden Age of Steam. The turn of the 20th century marked an era of unprecedented industrial expansion. By the time the calendar flipped to 1900, the Baldwin Locomotive Works was no longer just an American manufacturing success story. It had evolved into the undisputed king of global rail transportation. If a country had a working railroad, there was a staggering probability that an engine bearing the Baldwin nameplate was pulling its heavy freight. From the steep, treacherous gradients of the Andes Mountains in South America to the vast, frozen expanses of the Russian Empire, Baldwin machines were the chosen instruments of mechanical progress. They were exported to Japan, to Egypt, to Australia, and even to Great Britain itself, the very birthplace of the steam locomotive. This global dominance was not accidental. It was the direct result of a manufacturing system honed to an absolute razor edge. Under the aggressive leadership of men like Samuel Vauquelin, an executive who practically lived on the deafening factory floor, Baldwin developed a production speed that baffled international competitors. Vauquelin championed the compound locomotive, a brilliant design that used high-pressure steam twice to maximize fuel efficiency. But his true genius lay in standardizing parts across dozens of different classes of engines. While European builders often treated each locomotive as a unique, artisanal project, Baldwin treated them as heavily standardized pieces of industrial equipment. If a boiler tube or a heavy driving wheel broke on a Baldwin locomotive operating in rural Brazil, the railroad operator could send a telegraph cable to Philadelphia and receive a perfectly matched replacement part on the very next outbound ship. This unmatched logistical supremacy made Baldwin the default choice for emerging nations trying to build their first national rail networks. It is a peculiar observation of business history that absolute dominance often breeds a subtle, deeply ingrained arrogance. Looking back at corporate empires at their absolute zenith, one can often spot a specific kind of danger hidden in plain sight. When a company controls an entire global market, the executives slowly stop looking over their shoulders. They start believing that the era they dominate will simply last forever. For Baldwin in the early 20th century, steam power was not just a commercial technology, it was an institutional religion. They had spent over 70 years perfecting the complex thermodynamics of boiling water and expanding steam. They knew exactly how to make iron and steel endure incredible physical pressures. Because they were the absolute masters of this specific, fiery science. They simply could not imagine a future world that would ever want anything else. The climax of this golden age arrived with a numerical milestone that seemed almost incomprehensible to rival manufacturers. In 1913, the Baldwin Locomotive Works completed its 40,000th locomotive. 40,000 massive, complex mechanical beasts forged from raw American iron and sent out to conquer the globe. This specific engine was not a standard, lightweight passenger puller. It was a massive, articulated steam locomotive built specifically for the Pennsylvania Railroad, expertly designed to drag incredibly heavy coal trains over steep mountain grades. It was the physical embodiment of everything Baldwin stood for: massive size, raw mechanical power, and unyielding steam technology. When that 40,000th engine proudly rolled out of the assembly hall, the sheer scale of the achievement cemented Baldwin as a permanent fixture in the American industrial pantheon. They held the best patents. They employed the most skilled labor. They held the most lucrative global contracts. However, this massive volume of continuous production came with a severe physical constraint. The Broad Street facility in central Philadelphia, which had seemed so incredibly spacious when Matthias Baldwin moved his small shop there in the 1830s, was now bursting at the seams. The massive factory was completely landlocked by the rapidly growing city around it. Finished locomotives literally had to be hoisted by massive wooden cranes over the busy city streets just to be loaded onto shipping tracks. The company was physically suffocating under the weight of its own colossal success. As the world marched forward into a new, mechanized century, Baldwin Locomotive Works stood alone at the very summit of the manufacturing mountain, completely unaware that the ground beneath them was about to shift permanently and preparing for a massive relocation that would change the company forever. Chapter 4: The Industrial City of Eddystone. By 1906, the reality of Baldwin's situation in central Philadelphia was undeniable. The Broad Street plant was an engineering marvel, but it was physically suffocating. You cannot build a modern industrial empire when you are forced to hoist 50-ton steam engines over crowded city sidewalks just to load them onto shipping tracks. The company desperately needed space. They needed a massive blank canvas to design the ultimate manufacturing facility. The leadership looked south along the Delaware River and found their salvation in a vast tract of land at Eddystone, Pennsylvania. What began as a slow, cautious transfer of the heavy iron foundries eventually escalated into the complete relocation of the entire Baldwin enterprise. The sheer scale of the Eddystone facility was difficult for the average citizen to comprehend. It was not merely a factory, it was a self-contained, perfectly engineered industrial city spanning roughly 600 acres. Baldwin built an infrastructure that rivaled actual municipalities. The complex boasted over 26 miles of internal railroad tracks, designed exclusively to move raw materials and semi-finished locomotives between the various colossal assembly shops. Giant steam-powered cranes traversed the ceilings of buildings so vast that workers often joked they had their own indoor weather systems. At its absolute peak during the First World War and the Roaring Twenties, Eddystone employed nearly 20,000 men. It was a closed loop of manufacturing perfection. Raw iron ore, coal, and steel arrived by river barge and external rail. It went into the roaring foundries and emerged as precision-engineered cylinders, massive drive wheels, and high-pressure boilers. Every single component, from the heavy chassis frames to the tiny brass gauges inside the engineer's cab, was manufactured strictly on site. The coordination required to manage this workforce and this volume of material was staggering, yet Baldwin executed it with a cold, rhythmic precision. During World War I, Eddystone became an indispensable asset to the Allied war effort. They were not just building locomotives for the United States. They were supplying the mechanical lifelines for Great Britain, France, and Russia. The factory ran relentlessly, day and night, illuminated by the hellish glow of the open hearths and the blinding sparks of thousands of grinding wheels. The surrounding towns swelled with immigrant labor, all drawn by the steady, lucrative wages offered by the Baldwin juggernaut. It was a complete ecosystem built entirely around the manipulation of heavy iron. The physical environment inside Eddystone was punishing. The noise was a continuous, deafening roar of drop forges smashing into red-hot steel, hissing steam valves, and the grinding of massive gears. Workers communicated through complex hand signals because shouting was entirely useless. Yet, there was an immense pride among the men who worked there. They knew they were building the exact machines that powered the modern world. A Baldwin man was a highly respected figure in the community. The company provided steady work, and in return it demanded absolute dedication to the craft of steam engineering. It is a recurring theme in the history of great American empires that extreme operational success often breeds a fatal institutional blindness. When a company reaches a point where its internal systems are so massive and so perfectly tuned to a specific task, the scale itself becomes a psychological trap. You look out over hundreds of acres of roaring furnaces, you watch thousands of men moving in perfect synchronization, and you see dozens of massive locomotives rolling out the doors every week. It is incredibly difficult for executives standing in the middle of that triumph to imagine that their entire mechanical paradigm is on the verge of obsolescence. The management at Baldwin looked at Eddystone and saw the absolute pinnacle of human engineering. They were printing money. They were fulfilling global contracts faster than anyone else on Earth. The sheer momentum of the operation gave them a false sense of invulnerability. They believed that because they had perfected the production of the steam locomotive itself was a perfect, eternal concept. Inside the massive drafting rooms of Eddystone, hundreds of engineers sat at rows of slanted wooden tables, constantly tweaking and improving the steam designs. They were entirely focused on making the mechanical horse bigger and stronger. They completely ignored the possibility that the world might not need a mechanical horse at all anymore. Eddystone was a monument to the golden age of steam, but it was also a gilded cage. The board of directors, sitting comfortably in their plush offices overlooking the Delaware River, were entirely comfortable with the status quo. While the fires burned brightly in the Eddystone foundries, A quiet, different kind of power was being tested in small, overlooked workshops far away from Philadelphia. The giant was sleeping deeply, completely oblivious to the changing winds of technology. Chapter 5. Ignoring the Roar of the Diesel. The 1930s brought a devastating economic depression to the United States, but it also brought a strange new sound to the American railways. For a century, the tracks had echoed with the rhythmic, heavy breathing of steam cylinders and the sharp blast of steam whistles. Now a low, continuous mechanical hum was beginning to cut through the mountain passes. It was the sound of the internal combustion engine. Specifically, it was the diesel-electric locomotive. This new machine did not boil water to create pressure. Instead, a large diesel engine turned a generator, which then sent electricity to traction motors mounted directly on the axles. It was a completely different mechanical paradigm, and it was about to rewrite the entire industry. At the Baldwin Locomotive Works, the reaction to this new technology was not curiosity. It was outright dismissal. The company was under the heavy influence of its legendary chairman, Samuel Vauquelin. Vauquelin was a giant of the steam age. He had started at Baldwin as a young inspector and had climbed all the way to the top by sheer force of will and engineering brilliance. He held dozens of patents for steam locomotive improvements. He understood the exact properties of expanding steam better than almost anyone alive. But this incredible expertise had created a fatal blind spot. It is a common tragedy in the history of great corporations that the very individuals who build an empire eventually become the greatest obstacles to its evolution. Vauquelin looked at the early diesel locomotives and saw only a chaotic mess of fragile electrical wires and overly complex moving parts. He publicly mocked the technology. He proudly declared to railroad executives and the press that steam would always be the supreme motive power for heavy freight. He argued that diesel engines were essentially expensive toys, entirely unsuited for the brutal, dirty reality of American railroading. According to the leadership at the Eddystone plant, railroads would never abandon the raw, proven power of a massive steam boiler for a delicate electrical generator. This stubborn refusal to acknowledge the future opened the door for a predator that Baldwin had never anticipated. The threat did not come from a traditional locomotive builder. It came from the automotive industry. General Motors had acquired the Electromotive Company and transformed it into the Electromotive Division, widely known as EMD. General Motors did not care about the romantic legacy of steam. They approached the railroad industry with the exact same cold, calculating logic they applied to building automobiles on an assembly line. General Motors recognized that steam locomotives required constant, expensive maintenance. A steam engine spent a massive portion of its life sitting inside a roundhouse, having its ash pans cleaned, its boiler tubes replaced, and its firebox rebuilt. Furthermore, steam engines required a massive infrastructure of water towers and coal chutes across the entire continent just to keep moving. Diesel locomotives, by contrast, could run for thousands of miles with only routine refueling. They were ready to work the absolute moment the engine started. They did not pound the iron rails with the heavy, destructive hammer blows of steam drive rods. While Baldwin engineers were busy designing even larger and heavier steam boilers in a desperate attempt to prove Vauquelin right, General Motors quietly began demonstrating the raw economic superiority of diesel. EMD sent sleek, standardized diesel units on nationwide tours, explicitly proving that they could pull heavy freight over steep mountain grades just as effectively as the largest steam behemoths. More importantly, the accountants at the major railroads began running the numbers. The daily cost savings in fuel, maintenance, and track wear were absolutely undeniable. The climax of this technological conflict was not a sudden explosion, but a quiet, irreversible shift in loyalty. The major railroads, companies that had been purchasing Baldwin steam engines for over 70 years, started secretly negotiating with General Motors. They began placing massive orders for standardized EMD diesel locomotives, relegating their aging steam fleets to secondary branch lines. Inside the massive assembly halls of Eddystone, the deafening roar of the steam foundries continued to echo, but the market share was silently slipping away. The executives at Baldwin had fundamentally misunderstood the business they were in. They thought they were in the business of building steam engines, when in reality, the railroads only cared about the most efficient way to move freight. By clinging fiercely to the past, the giant had willingly surrendered the future. Chapter 6: Clinging to Past Glories. The 1940s brought a desperate energy to the massive assembly halls of the Eddystone plant. The executives at Baldwin Locomotive Works could no longer pretend that the diesel-electric locomotive was a passing fad. General Motors was taking aggressive bites out of their market share. Railroads across the country were running the numbers and discovering the undeniable economic advantages of diesel power. Confronted with this existential threat, Baldwin did not pivot. They dug their heels in. They decided that if they were going to lose on efficiency, they would simply overpower the competition. They would build steam locomotives so massive and so incredibly powerful that no railroad could possibly ignore them. This decision initiated an era of mechanical gigantism. Baldwin engineers were instructed to push the absolute physical limits of steam technology. They designed boilers that operated at terrifyingly high pressures. They built massive articulated engines with multiple sets of driving wheels, designed to drag miles of heavy coal cars over the steepest mountain passes in the country. They collaborated with longtime customers, like the Pennsylvania Railroad, to create experimental high-speed passenger locomotives, such as the famous rigid-frame duplexes. These machines looked magnificent. They were sleek, aggressively styled, and capable of generating unbelievable amounts of raw horsepower. On paper, they were the absolute pinnacle of locomotive engineering. But the harsh reality of the railroad tracks told a very different story. It is a tragic paradox of industrial history that when a dying technology attempts to save itself, it often becomes so overly complex that it actually accelerates its own demise. To extract more power from steam, Baldwin had to make the engines heavier and far more complicated. The resulting locomotives were absolute monsters. They weighed hundreds of tons. When they operated at high speeds, the massive steel driving rods pounded the iron rails with such tremendous force that they literally destroyed the tracks. Track maintenance crews were constantly dispatched to repair the severe damage caused by these new super locomotives. Furthermore, the internal complexity of these late-stage steam engines was an absolute nightmare for the maintenance departments. A diesel locomotive could be serviced relatively quickly with standard mechanic tools. Maintaining one of Baldwin's giant experimental steam locomotives required specialized, brutal labor. Mechanics had to crawl inside still hot fireboxes to replace fragile boiler tubes. The massive moving parts required constant, heavy lubrication. The advanced, high-pressure steam systems were prone to catastrophic leaks. A locomotive does not make any money for a railroad when it is sitting inside a repair shop, and these new Baldwin giants were spending a staggering amount of time in the shop. The operational costs were simply unjustifiable. These massive steam engines consumed astronomical amounts of high-grade coal and premium water. They still required a vast network of supporting infrastructure across the country. Meanwhile, the sleek diesel units from General Motors were running smoothly for thousands of miles with minimal attention, burning cheap fuel and leaving the tracks perfectly intact. The economic contrast was no longer a theoretical debate among engineers. It was a brutal reality reflected on the balance sheets of every major railroad in North America. The turning point came when the executives of the major railroads finally reached their absolute breaking point. These were men who had bought Baldwin products for their entire careers. They had deep, historical loyalties to the Eddystone plant, but they were also businessmen. They looked at the spiraling maintenance costs, the horrific track wear, and the poor availability of the new super steam engines. The loyalty finally snapped. In boardrooms across the country, quiet but devastating decisions were made. Railroad after railroad issued public statements declaring the end of their steam purchasing programs. They canceled pending orders for new steam locomotives. They announced comprehensive plans to dieselize their entire fleets. For Baldwin, it was a catastrophic blow. The very customers they had spent decades cultivating, the customers they had built these massive new machines to impress, were walking away. The Eddystone plant continued to roar, but the fires in the foundries were beginning to look less like a beacon of industry and more like a massive funeral pyre for the golden age of steam. The giant had tried to fight the future with sheer brute force, and the future had simply refused to buy it. Chapter 7. The Late Awakening. The atmosphere inside the executive offices at the Eddystone plant shifted from stubborn denial to absolute panic. By the late 1940s, the order books for new steam locomotives were essentially empty. The major railroads had made their final, irreversible decisions, and the verdict was diesel. General Motors was running away with the market, churning out highly standardized units by the hundreds. Baldwin Locomotive Works, the undisputed giant of the previous century, was suddenly fighting for its very survival in an industry it used to control. The board of directors finally mandated a complete and total pivot to diesel-electric manufacturing. But acknowledging a new reality is not the same thing as mastering it. General Motors had spent over a decade perfecting their diesel designs. They had engineered their engines, generators, and traction motors from the ground up specifically for the demanding environment of railroad applications. Baldwin, on the other hand, had virtually no institutional knowledge of internal combustion engines or high-voltage electrical systems. For over a century, their massive engineering department had focused exclusively on the thermodynamics of boiling water and expanding steam. Now, those same engineers were asked to suddenly understand complex fuel injection timing and intricate electrical relays. It is a harsh reality of industrial pivots that a massive corporation cannot simply buy time with money. Deep technical experience must be brutally earned through trial and error, and Baldwin had absolutely no time left to fail. Because they could not design a complete system in-house quickly enough, they were forced to become an assembler of outsourced components. They formed a strategic partnership with the Westinghouse Electric Company to supply the massive traction motors and generators. For the beating heart of the locomotive, the diesel engine itself, they turned to the De La Vergne Engine Company, a subsidiary they had acquired years earlier. This piecemeal approach was fundamentally flawed from the very beginning. The De La Vergne diesel engines were incredibly robust, but they were originally designed for stationary power plants and marine applications. They were massive blocks of iron that operated best at very low, constant speeds. To make them fit inside a locomotive and generate enough power for rapid acceleration, Baldwin engineers had to push these engines far beyond their original design parameters. They bolted these heavy marine engines to complex electrical systems they barely understood, hoping the combination would somehow rival a purpose-built machine. Furthermore, Baldwin simply could not break its century-old habit of custom manufacturing. General Motors offered a strict catalog of standardized locomotives. If a railroad wanted an EMD unit, they picked a model and accepted it exactly as built. This ruthless standardization was the secret to EMD's reliability and cheap maintenance. Baldwin, however, continued to treat every diesel order like a custom steam engine contract. If a railroad wanted a slightly different electrical layout or a heavily modified cab design, Baldwin eagerly agreed to build it. As a result, almost no two batches of Baldwin diesels were exactly alike. They desperately tried to mask these internal engineering flaws with striking exterior designs. Baldwin hired famous industrial designers to create aggressive, futuristic metal car bodies. The most famous of these was the shark nose design, featuring a sharply raked front end that looked incredibly fast and intimidating. But a beautiful exterior could not compensate for a dysfunctional interior. The sleek metal shells merely hid a chaotic tangle of incompatible technologies. When these new Baldwin diesels finally hit the rails, the operational results were disastrous. The mismatched components constantly fought against each other. The heavy de Laverne engines vibrated violently when pushed to high speeds, literally shaking the locomotives apart over time. Engine oil leaked profusely onto the tracks and seeped into the sensitive electrical compartments. The complex custom-wired electrical systems were incredibly fragile and prone to frequent, unpredictable short circuits. Mechanics working for the railroads despised the new Baldwin machines. With standard General Motors units, a broken part could be swapped out in minutes with an identical replacement from the shelf. With a Baldwin, the mechanic often had to study a custom schematic just to figure out how that specific locomotive was wired before he could even attempt a repair. Locomotives spent weeks languishing in repair shops, waiting for specialized parts to arrive from Eddystone. The railroads that had purchased these early units out of deep, historical loyalty to the Baldwin name quickly realized their expensive mistake. The attempt to catch up to the future had completely backfired, proving to the entire industry that the master builders of steam were entirely lost in the age of diesel. Chapter 8. The Unstoppable Freefall. The dawn of the 1950s brought a cold, unforgiving reality to the massive Eddystone complex. The initial foray into diesel-electric manufacturing had been a public and highly expensive disaster. Railroads that had tentatively tested Baldwin's new machines were now actively trying to return them or relegate them to the most obscure switching yards. The company was no longer viewed as the majestic king of the rails. It was rapidly becoming an industry cautionary tale. The fundamental problem was not just mechanical, it was deeply cultural. For over a century, Baldwin Locomotive Works had operated on the philosophy of the artisan craftsman, applied on a massive industrial scale. If a railroad executive requested a steam locomotive with a slightly larger firebox, a different wheel arrangement, or a custom cab layout, the drafting department eagerly complied. This flexibility was the very cornerstone of their historical success. But the diesel era did not reward custom craftsmanship. It demanded absolute, rigid standardization. It is a brutal irony of industrial evolution that the exact traits making a company indispensable in one era can make it entirely irrelevant in the next. Baldwin simply could not stop treating every single order as a bespoke engineering project. When they received orders for their new road switcher diesels, they allowed railroads to dictate internal component placements, electrical configurations, and even the layout of the control stands. As a result, the factory floor at Eddystone was a chaotic mess of varied production lines. They were building dozens of different variations of the same underlying locomotive. This stubborn adherence to custom manufacturing destroyed their ability to achieve economies of scale. Production costs skyrocketed because parts could not be ordered in massive, uniform bulk. Assembly line workers constantly had to consult custom blueprints for every individual unit, drastically slowing down the manufacturing pace. Meanwhile, out in the field, this lack of standardization continued to torture railroad maintenance crews. Even locomotives from the exact same production batch could have entirely different wiring schematics. Across the industrial landscape, General Motors was executing a masterclass in ruthless efficiency. The Electromotive Division operated with cold, automotive discipline. They offered a very limited catalog of diesel locomotives. The famous F-Unit series and the subsequent GP series were built exactly one way. If a railroad wanted an EMD locomotive, they accepted the standard design. This rigid discipline allowed General Motors to churn out thousands of identical units at a blistering pace. Because every locomotive was identical, Spare parts were cheap and universally available. A mechanic in California could repair an EMD locomotive using the exact same manual and parts as a mechanic in New York. The economic contrast was absolute and devastating. General Motors was driving down the cost of railroading, while Baldwin was artificially inflating it with unnecessary complexity. The market share numbers from the early 1950s reflect a complete corporate freefall. Railroads were ordering EMD units by the hundreds, while Baldwin was fighting tooth and nail just to secure orders for batches of 5 or 10 specialized switching locomotives. Baldwin was rapidly losing its core identity. They were no longer the proud architects of American transportation. They were a niche manufacturer surviving on scraps left behind by General Motors. They tried desperately to update their product line, introducing the standard line of diesels in a belated attempt to mimic EMD. But the damage to their reputation was already terminal. The new locomotives were certainly better than their disastrous early attempts, but they were still saddled with the heavy, slow-revving de la Vergne engines and complex Westinghouse electrical gear. Railroad executives simply had no reason to take another risk on a Baldwin product. General Motors offered a proven, highly reliable machine backed by a massive, perfectly organized parts network. Baldwin offered lingering mechanical uncertainty and a legacy that meant absolutely nothing to the modern accountant. Inside the cavernous halls of Eddystone, the atmosphere grew increasingly bleak. Entire sections of the massive 600-acre facility were completely darkened and shut down. The roaring fires of the steam foundries, which had once illuminated the night sky for miles around, were permanently extinguished. The thousands of highly skilled boilermakers and steam fitters, men who had dedicated their entire lives to the art of manipulating heavy iron and pressurized water, found themselves completely obsolete. Many were laid off, while others were clumsily reassigned to bolt together electrical cabinets they did not understand. The profound silence in the abandoned steam shops stood in stark, depressing contrast to the frantic, panicked energy in the shrinking diesel assembly bays. The giant was not just falling, it was being hollowed out from the inside. Chapter 9. Desperate Mergers. The sheer panic inside the executive boardrooms at Eddystone was palpable. As the 1950s progressed, Baldwin Locomotive Works was bleeding money at an unprecedented rate. The core business of building locomotives, which had sustained them for over a century, was rapidly collapsing under the relentless pressure from General Motors. When a massive industrial entity realizes its primary product is no longer viable, the immediate corporate reflex is almost always identical. They try to buy their way out of the crisis through aggressive mergers and blind diversification. In 1950, Baldwin merged with the Lima-Hamilton Corporation. Lima was another historic giant of the steam era, famous for building some of the finest freight locomotives in American history. On paper, this merger might have looked like a consolidation of immense heavy manufacturing power. The new entity was formally christened the Baldwin-Lima-Hamilton Corporation. But in the brutal reality of the marketplace, it was merely two drowning men clinging to each other in the middle of a raging ocean. Combining two massive, outdated steam manufacturing facilities did absolutely nothing to solve their mutual inability to build a competitive, standardized diesel-electric locomotive. It is a fascinating, if grim, observation of corporate behavior that companies in terminal decline often mistake sheer size for actual strategy. Instead of ruthlessly streamlining their chaotic diesel production to compete with General Motors, the newly formed Baldwin-Lima-Hamilton decided to look everywhere except the railroad tracks for salvation. They embarked on a frantic campaign of extreme diversification, hoping to find a magic bullet that would replace their lost locomotive revenue. The executives ordered the massive Eddystone plant to start manufacturing an incredibly bizarre array of heavy industrial products. The factory floors that had once given birth to 40,000 steam locomotives were suddenly tasked with building massive hydraulic turbines for hydroelectric dams. They began manufacturing heavy earth-moving equipment, massive rock crushers, and specialized road-building machinery. They even produced complex testing equipment for metallurgical laboratories and heavy ordnance for the military. This desperate scattergun approach completely shattered whatever remained of their operational focus. Building a massive hydraulic turbine requires an entirely different engineering mindset, a different supply chain, and a different manufacturing rhythm than building a locomotive. The corporate culture at Eddystone became a disjointed, chaotic mess. Engineers who had spent their entire careers specializing in train dynamics and track adhesion were suddenly forced to learn the intricacies of soil compaction equipment. The sales teams, historically accustomed to negotiating exclusively with railroad presidents and chief mechanical officers, were now fumbling through attempts to sell rock crushers to municipal highway departments. While this extreme diversification brought in some temporary revenue, it was an absolute operational nightmare. The fixed overhead costs of simply maintaining the massive 600-acre Eddystone facility, with its miles of internal tracks and colossal assembly halls, were staggering. Selling a handful of earth-moving machines or a single dam turbine could not possibly cover the massive financial losses pouring out of the dying locomotive division. The company was spreading its remaining resources incredibly thin, performing dozens of different manufacturing tasks poorly instead of mastering the one task that had built their empire. The final, fatal blow did not come from a competitor on the rails. It came from within their own boardroom. The Westinghouse Electric Company, which had partnered with Baldwin for years to supply electrical components for their flawed diesels, had slowly acquired a massive block of Baldwin stock. By the mid-1950s, Westinghouse was the dominant, controlling shareholder. Westinghouse was a modern, unsentimental corporate machine. They looked at the Baldwin Lima Hamilton financial statements without any nostalgic reverence for the golden age of steam. They saw a massive, bloated manufacturing complex in Philadelphia that was hemorrhaging cash at a frightening pace. They saw a disjointed product line, a chaotic factory floor, and a locomotive division that held barely 4% of the market, having permanently lost the war against General Motors and the American Locomotive Company. The Westinghouse executives applied cold, clinical corporate logic to the problem. They decided it was absolutely pointless to continue pouring millions of dollars into a dying brand just to keep a historical legacy alive. The financial spigot was abruptly and permanently turned off. Westinghouse issued a brutal, uncompromising corporate directive. The locomotive division, the very beating heart of the Baldwin Empire since the days of Matthias Baldwin and Old Ironsides, was to be completely liquidated. The desperate mergers and the chaotic attempts at diversification had completely failed to save the company. They had only prolonged the agony. The industrial giant was finally out of time, out of money, and out of options. Chapter 10. The End of a Legend. The year 1956 arrived not with the deafening roar of industrial triumph, but with the hollow, echoing silence of surrender. Inside the sprawling Eddystone complex, a profound stillness fell over the massive assembly halls that had once been the beating heart of American transportation. The decree from the Westinghouse executives was absolute and final. Baldwin Locomotive Works, the company that had defined the golden age of rail travel, was to cease all locomotive production permanently. It was an astonishingly quiet death for a titan that had forged its towering reputation in fire and steel. The physical dismantling of the Eddystone plant was a prolonged, heartbreaking spectacle. This was not merely the closure of a factory, it was the systematic erasure of a functioning industrial city. The colossal overhead cranes, which had once effortlessly hoisted 70-ton boilers through the air, were deliberately cut down and sold for scrap metal. The massive brick foundries, where generations of men had endured hellish temperatures to pour molten iron, were systematically demolished. The intricate web of 26 miles of internal railroad tracks was violently ripped from the earth. Piece by piece, the 600-acre monument to steam power was reduced to vast, empty fields of concrete rubble and twisted rebar. The human cost of the collapse was even more profound than the physical destruction. Thousands of highly skilled craftsmen found themselves abruptly cast out into an economy that no longer valued their specialized knowledge. Boilermakers, heavy iron riveters, and steam dynamics engineers realized that their lifelong trades had vanished almost overnight. These were men who possessed an almost intuitive understanding of how to make heavy metal flex and breathe under extreme pressure. They had spent decades building the massive, articulated engines that conquered the Rocky Mountains, and the sleek passenger locomotives that raced across the flat Midwestern plains. They had shipped their iron creations to every corner of the globe, bringing modern transportation to developing nations on 6 continents. Yet, they were left entirely behind by the march of progress. The local communities surrounding Eddystone, which had thrived for decades on the steady, lucrative wages provided by the locomotive giant, plummeted into deep, lasting economic despair. It is a sobering reality of industrial history that no corporate empire, regardless of its immense size or historical significance, is ever truly immune to the brutal forces of technological evolution. The sheer scale of past success often creates a rigid, impenetrable fortress of arrogance. Baldwin had operated under the fatal delusion that their total mastery of steam engineering made them invincible. They believed that because they had built over 70,000 locomotives, the world would patiently wait for them to dictate the future. They had fundamentally failed to understand that the transportation industry is bound by strict economics, not by romantic nostalgia. When General Motors offered a cheaper, significantly more efficient way to move freight, the railroads simply walked away from their historic loyalties without a second thought. The final Baldwin locomotives built at Eddystone were a small batch of diesel switchers delivered in 1956. There was no grand ceremony, no marching bands, and no triumphant speeches from corporate executives to mark the occasion. The last engines simply rolled out of the massive doors, the factory lights were extinguished, and then the doors were permanently chained shut. The once mighty Baldwin Lima Hamilton Corporation completely pivoted to heavy construction equipment and industrial machinery, trying desperately to erase its locomotive heritage in order to survive. However, even that scattered strategy eventually resulted in total corporate dissolution in the early 1970s. Today, only scattered remnants of the Baldwin legacy survive. Across the country, dedicated railway museums carefully maintain a few surviving Baldwin steam engines, preserving them as magnificent, breathing artifacts of a bygone era. When these meticulously restored machines are occasionally fired up for public demonstrations, the ground trembles, the air fills with the sharp scent of coal smoke, and onlookers are briefly transported back to a time when Philadelphia iron ruled the world. But these surviving engines are essentially ghosts. They serve as a powerful reminder of what the company once was, but they also highlight exactly why the company failed. Matthias Baldwin had started his enterprise in a tiny jewelry shop, driven by a relentless desire to innovate and adapt. The corporate giant that bore his name ultimately perished because it forgot that very founding principle. They did not die because they forgot how to build great machines. They died because they refused to look up from their drafting tables and see that the world had already moved on.